Okay, good. So that's what we have. Can you look at this? Look at this. What do we have here? 0.5. What do we have here? What do we have here? Now, I'll ask you a quick question. Whenever you take samples, will you have the same proportion? Do you realize then that tends the estimate of the proportion and makes it a random variable? Because what is a random variable? It's random. You won't get the same answer, right? So if it's random, then you can actually find the probability of actually observing a certain observation of that random variable, of realizing a certain observation. So that's what I'm saying. That is why now they are saying the sampling distribution. What is the sampling distribution? It is actually the distribution of what? P bar. Because once I know the distribution of P bar, then I can actually calculate the probability, or rather probabilities related to this. And this is very important because we need it for something called inference, right? Are you happy? So do you realize what is happening here? I did this on purpose. I did this on purpose. Now I want to illustrate it. I don't know if there's a word diagrammically, but if there isn't, take it. So, what I want to say is we've got a population, right, which was the class, right? And what we want to define our proportion as, P, is the proportion of girls, right? So we're looking for the proportion of girls in the class, right? So, do you realize what we did? We took a sample from this, right? And then we calculated P hat. We took another sample, calculated P hat. Took another sample, calculated P hat, and they were not the same, right? So then we said that makes P hat a random variable. What makes it a random variable is that when you calculate it from different things, you will not get the same value. You will not get the same value. Understand? So now, remember last time we had a variable x, and we said, let's say we were, what variable was I talking about? Of course I know I didn't talk about weight, because at that time I was still dealing with mine. So I spoke about height, right? I said we can have a random variable x, it's a height of a student, and we said the height of a student is normally distributed, right? So what we said is, we said, okay, let's go for the height of a student. So we've got the height of a student. We said x is normally distributed, and what did we put in here? We said it needs parameters. First of all, we said x is a continuous variable, right? And then we said it needs parameters. What did we say the parameters of a normal distribution are again? There's two parameters. We put something here and we put something here. It needs the mean, right? It needs the standard deviation or the variance, right? So what you did, you put in mu there, right? Do you realize that? You put in mu and then you put in sigma. Remember? Do you remember that? And I said you needed that. And I said you needed that to do what? To standardize, right? What is to standardize? It's to zetify, right? So that's when you calculate z. You take whatever, you subtract its mean, divide by standard deviation, right? That is why you need these parameters, right? And why do you zetify? Because you want to go to the z tables and find probabilities, right? I'm going somewhere here. Please come with me, okay? Come with, don't get left behind. So now, do you realize this context? Now we are saying the sampling distribution of P bar is approximately normally distributed. Do you realize that if we're saying P hat is approximately normally distributed, we need the mean of P hat. We need the standard deviation of P hat. That's the only way we will be able to zetify. Are you happy? Now, P hat The mean here, do you remember? Sorry guys, I'm going to take you back just a bit so that we build up this theory. Remember here, what is this? This is x bar, right? What is x bar? What is x bar? In your, what is x bar? What is x bar? You just saw something like this, ne? Because I know you knows it. X bar. X bar is also a mean, right? But x bar is the mean of the sample. This is the mean of the population. Same concept, right? So this is the proportion of the, now, do you understand, before we even go to the conditions, do you understand what they mean when they say P bar, there you go, P bar is approximately what? Approximately normally distributed with its mean being P. Do you see that? How nice. We had X here and we said it's normally distributed and its mean is the population mean, right? So P bar will have its mean in the population proportion. That's what they are talking about here. And then it will have its standard deviation or variance being nothing but the population proportion times 1 minus the population proportion over your sample size. Are we happy about this? Do we get this now?